Before introducing the various functions of FFlex one by one, let me show you the 4 demos about how to use MFBD with RecurDyn. Rather than explaining each function, it is easier for you to understand how to use MFBD. First one is an MFBD simulation of a long-length body. There is a long body. Let's simulate this rigid body first. It is fixed with a fixed joint on the left, and a downward force is applied to the right side of the body. The simulation ends quite fast. Since this is a rigid body simulation, there is no body deformation. We cannot see the stress distribution. However, the reaction force of the joint can be viewed for sure. This time, I will convert this body to a flexible body. I will convert it using G Manager. If you click G Manager and select a body, a dialog appears. We can understand this as convert rigid body to full flexible body. Other options will be maintained as defaults. Click Execute to enter the measure mode. I will use AutoMesh here. Use the solid 8 element and input 10 for both max element size and minimum element size. See the left side where the fixed joint was attached. This is an FDR that was automatically created. A master node is created on the location where the joint is attached, and the nodes close to the master node are used as slave nodes. To define a joint or a force, FDR is required and RecurDyn automatically creates it. The right side of a long body is similar to the left side. Force must be applied to an FDR, so the master node is created and the nodes close to the master node are used as slave nodes. Exit the measure mode. On the left, a fixed joint is connected to the FDR, and the force on the right is applied to the FDR on the right side. Now let's run a simulation. After the simulation, it is possible to view a slight body deformation and stress distribution using contour plot. In order to see the contour, min-max values must be calculated or input manually. See, we can see the stress distribution. The second demo is a suspension simulation. First, let's convert this body to a flexible body. Use G Manager to enter the measure mode. Click G Manager and select this body. Before mesh, let me click Assist. You will see 3 names, which are information of the FDR that will be created for the joint and bushing forces connected to 3 holes of the body. For spherical joint, it is better to select the inner face of the hole than this face, so I will change it. The faces for bushing force are selected properly. Now, click AutoMesh and input 10 for min-max values and leave other options as defaults. After mesh is created, if you look at the 3 holes, FDRs are created in each hole. Then exit the measure mode. Let's run a simulation. After the simulation, we can view an animation and a contour plot of the stress distribution. You can use plot to draw the result graphs. How to analyze the joint, force, and contact results is the same as the rigid body. For a flexible body, the results of nodes are written instead of body ones. Currently, you can see only 3 node results. If we define output, more node results are written here. Please be careful because the file size can become huge. It can be bigger than several gigabytes if you define too many nodes as output. Therefore, only positively necessary nodes should be defined as output. Please note that you can also check the results of the nodes that are not defined as output using node scope. After opening a FFlex body dialog box, select Non-Output Node in the Node Scope tab and click Scope. After that, after selecting a node, you can draw the graph of the node results. The third demo will show you how to create FDRs manually. Double-click a flexible body to enter the FFlex body edit mode. I will delete an automatically generated FDR and recreate it manually. Since FDR is an element, click Select Element on the left toolbar, then click the FDR icon and press the Delete key. The number shown in the middle is the master node ID. Let's delete this master node as well. This time, after clicking Select Node and choosing the node, press the Delete key. I will manually create an FDR that I have deleted. First, display the markers. Three markers are the ones connected to the joint and bushing force, respectively. Click the Node button and click N, then select the marker in the middle. Then one node is created where the marker is located. This will be used as a master node. I will create a node set for slave nodes this time. Click the node set and since I will select the nodes around this hole, after clicking the Add Remove button, I click this Select by Circle in the left toolbar and draw a circle from the center. Then surrounding nodes are selected. Since the node in the middle is used as the master node, it must be deselected. If you hold down the Ctrl key and select the node, it is deselected. Finish the operation. The node cell was created as you can see in the database. Click the FDR button and select the node in the middle as the master node. Select the node set as the slave node. Then an FDR is created. In fact, this FDR is slightly different from automatically created FDR, but it is for educational purpose. I think this is enough for now. The procedure to create an FDR seems quite complicated, doesn't it? However, RecurDyn has automated this procedure. Please remember the previous demo videos. In Assist Modeling dialog box, the only thing I modified was the selection of the face around this. And everything else was handled automatically. The fourth video is about context simulation. This model has one box and one sphere. Let me simulate this model first. Then the sphere falls on the box. Let me convert the box to a flexible body with GManager. Open the Assist Modeling dialog box, then the bottom face is already selected, and it is used for FDR for the fixed joint on the bottom face. And the geometry listed in the below part of the dialog box is the geometry where a patch set will be automatically created. Here, the entire box is selected. Let me show you how to use Advanced Mesh this time. For a shape with 4 edges, Advanced Mesh can create a higher quality mesh than Auto Mesh. Let's use Shell 4 and input 50 and 50 for min-max respectively. As you can see, FDR is created at the bottom, and a patch set is also created. Now exit the mesher. Let me run a simulation. On my PC, the simulation took a while, but I edited it to save time for this lecture. Now you can see the animation. Let's create a more efficient patch set. Double-click the box to enter the FFlex body edit mode. In the Set Patch 1 dialog box, click the Add Remove Continuously button and select only the top face. If you create a patch set like this and simulate the model, the simulation time is reduced to 33 seconds. This is the animation and contour plot of the results. Since we know where the contact occurs, we can create a patch set more efficiently. Let's go back to the FFlex body edit mode and select only 4 patches used for contact. If we simulate the model with this patch set, the simulation time is reduced to 30 seconds, allowing you to save more time. It took 30 seconds. One more thing. Let me introduce self-contact briefly. Since RecurDyn uses patch set for the contact between flexible bodies, we can define contact even between the patch sets in one body. As you can see, self-contact can be defined using patch sets in different locations in one body. I will end this lecture here and continue it in the next one. After watching all the MFBD kit courses, don't forget to try the workshops in the below link here. Thank you.